Hello, everyone, and welcome to the 2023 Feed Production Workshop. I'm Martin Winchell, Marketing Manager for Alltech's Mycotoxin Management Program. For those of you who have joined us at some of our previous sessions, welcome back. And for those of you who are attending for the first time, you are very, very welcome. These sessions continue to prove very popular, and once again, we have attendees joining from all corners of the world. So what are we going to talk about today? Well, primarily, we're focused on one of the first steps in feed production, the intake of ingredients at the feed mill. Josh Teulker will talk to us about preparing a feed mill for grain intake. John Winchell is going to look at some of the latest technology in mycotoxin control. For the first time, we're excited to be joined by a representative from Bühler Group, who will share some exciting developments in the area of grain sorting. To wrap up our formal presentations today, Josh Teulker will come back in to discuss the best practices in designing a robust quality control program. One of the key features of these sessions in the past has been the excellent interaction between the audience and our speakers. So we once again encourage you to place all your questions and comments in the chat, and we will have time for a Q&A discussion at the end of the presentations. Before we begin, I would just like to thank each of our speakers for joining us today, as well as the preparation they've put into getting ready for today's event. Josh is going to kick us off today and explore the topic of preparing a feed mill for grain intake. Josh has been a regular at our feed mill workshops for the past few years, and although he officially left Alltech last year, he still acts as an external feed mill consultant on our mycotoxin management team. Josh, you've got many years of valuable experience in the feed production sector, and we look forward to you getting us started today.
Well, Martin, thank you very much for that introduction. As Martin said, I'm going to talk about preparing for grain intake at your feed mill for the next 20 minutes or so here. Yeah, it's nice to be back here at the workshop. Usually I'm on the other side where Martin is. So this is kind of nice to just be back here presenting and not running the entire event. So let's get started. All of us here probably work in a feed mill facility of some sort, and we're going to have some type of grain coming into our feed mills. And that's what we want to talk about today, how to prepare for grain coming into our feed mills. And really, it needs to start with a plan at your facility. And what I mean by that is you got many steps in receiving, from the start being finding suppliers for your grain. It starts kind of outside of your feed mill. And once you find those suppliers, you have receiving and all these other steps in between storage. And having some type of plan to incorporate all those steps and make sure that you're ready at each step in the feed mill is super important. And that's kind of what we're going to go over today. So just an overview. First, we want to have a trusted supplier coming into your feed mill. As I said before, you're going to have suppliers that are supplying you with grains coming into your mill. If those suppliers are someone you have problems with, if they're inconsistent, all that stuff is hurting you in the end when you're storing these grains. So if you don't have trusted suppliers, you want to make sure we have trusted suppliers. The most important step of all this that I'll go into a lot more detail is that we want to have a way of taking a proper sample at receiving. And I'll tell you why that's important later on. We also want to have all the adequate testing equipment at our feed mill, whether that be testing for moisture or foreign material or mycotoxins. We also want to make sure that testing method works for our feed mill. Maybe not every feed mill needs a mycotoxin quick test at their feed mill. Maybe you can send that off to a third party, and we'll talk a little bit about those scenarios as well. We want to make sure that once we have all these steps in place, we're ready to store our grain. We're going to talk about how to get bins ready for storage, or your feed mill ready for storage of ingredients. And then finally, once we have the bins ready, we want to make sure we have a plan for when those grains or ingredients are going to be stored. Some other key things to realize is that no matter what we do, all grains coming into our feed mill are going to have some type of quality issue. They're going to have, certain years we're going to have mycotoxins in our grains. There could be some foreign material. You're always going to have some percentage of foreign material in your grains. But for the feed mills, we got to understand what levels of all of those quality issues are acceptable for the species we're feeding or for our customers that we're sending this feed to. So we got to have some type of understanding of the grains coming in and also what's acceptable for our feed mills. And what I mean by that is pretty simple. Like if you're a feed mill that feeds a lot of ducks, you can't have much aflatoxin in your grains. Whereas you're feeding layers, you can get away with a little more mycotoxins. So those are things you got to think about and assess at your feed mill at receiving. Also, we want to make sure we set up a program that's going to work for your mill and also work for your customers. You know, if you're your feed mill that's doesn't have the resources that your customers are requiring, that's some changes you're going to have to make at your feed mill, and vice versa. If you have some customers that their expectations are higher than what your feed mill can provide, then you're either going to have to find new customers or adapt to those customers. And then finally, as I said before, think about ways you can start to hold suppliers accountable for the products they're delivering. And I'll talk about that a little bit more at the end of the presentation here. So as I said before, sampling is, in my opinion, probably the most important aspect of receiving in grain. And the reason I say that is, if you really think about it, if you take a poor sample at your receiving area, say like, for example, this picture behind you, behind the chart here is of a hydraulic probe taking a probe of a corn truck. Let's say that probe took a sample where you could see it right there in the truck, and the only thing they did was they grabbed that one probe and that was it. And it happened to be where that probe was that they had a real high level of DON right there, and the whole rest of the truck was perfectly fine with no DON in it. Well, if you would have taken a poor sample and just taken one probe, you're going to think you had a horrible DON problem, and when in reality you can't. So a sample can a bad sample can give you a problem that you actually don't have, and vice versa. It can give you a problem that or it can cause an issue with you know, same exact scenario. If this truck was contaminated with DON and you happen to only take one probe and that probe happened to not have any DON in it, you're going to be feeding the species a high level of DON that you didn't catch at receiving. So taking a proper sample is super important. How many samples do I need to take in the feed mill? That's going to depend on the mill and what you're feeding, what your grain intake levels are. You know, some years, if you're having horrible issues with mycotoxins, you may need to take many more samples and test many more times. You also need to think about what's your best option for taking samples. Does your mill have a nice hydraulic probe like this? If not, can we reach the tops of grain trucks with a sampling probe? Can employees safely get to the grain to take samples? If those two options really aren't available, you probably need to make some changes at your feed mill and figure out how employees can safely take samples efficiently. Probably the biggest thing I see is that employees do not understand why a sample is so important, and if they don't, they need to. It's probably the easiest way to cut corners at a feed mill is to just take one little probe of grain out of the truck and call that your complete sample, and we don't want that to happen. So we need to really educate the employees taking grain samples how important that step is in receiving. And as always, you want to have some type of a sampling plan. I decided not to get into a whole bunch of details on sampling in this PowerPoint because I could have talked about it for 20 minutes alone, but Alltech does have some really good resources on how to take a proper sample in many different scenarios. So if you could just reach out to your Alltech representative, we can get you that little handout we have to show you how to take a proper sample. Okay, so now that we know we have to take a proper sample at receiving, we have to prepare for what we're going to do with those samples, and that's typically run some type of test on them. And this is something John Winchell is going to get into a lot on the next presentation during this workshop here. But we got to think about it at our feed mill. How often are we going to test these samples coming in? What are we going to test for? Do we need to buy something like the Neogen Raptor and test on a regular basis? Is our moisture readers properly calibrated before we start to have a lot of grain intake at our feed mills? Does all the employees, are they all trained on these processes to test for these proper samples we're taking? Time is something that most mills struggle with, and oftentimes we really struggle with it at receiving, especially for feed mills that have seasonal receiving times, like in the US, October and November, when grains are coming off the fields and harvested. Oftentimes feed mills will have lines of grain trucks coming in for long-term storage, and those farmers are coming in with large grain wagons that essentially are their lifeline to get back out in the field and keep their operations moving out in the crop fields. And us telling a farmer that we have to take a 10-minute mycotoxin test on all your loads may not go over well with them. So we have to be prepared to have those conversations, get ahead of that kind of stuff so people are aware of it and can plan accordingly. So think about that timing aspect of all this whenever you are implementing some type of testing. A moisture test and all that's pretty standard when it comes to feed bills, but if you're going to start testing for mycotoxins, think about your suppliers and give them a heads up before you implement these, kind of surprisingly to them. Okay, so now that we have a proper sample and we know what we're going to test the incoming ingredients for, we have to have our bins ready for the incoming grain. And something that's not very fun to do, but it's very necessary, is to clean your bins. You need to cleaning and inspecting bins on a regular basis will prevent mold growth inside your bins. You don't want that old nasty crusted grain or ingredients inside your bins. If you have that, you need to clean it off and discard it. Something else I'd recommend looking into is some of the bin sweeps or grain vacuums. They're really essential tool for a thorough cleaning of a grain bin. And I will say this, over the last several years, that technology has actually come a long way, and they really make some nice products that are safe and easy to use for employees. With that all being said, there's still bin sweeps and vacuums. It's not a fun job. It's not a pleasant job, but there is technology now that has made it quite a bit more efficient than it was in the past, and safer as well, which is always important. Once you have those bins cleaned out and ready to go, we do need to do some inspections. For example, you want to make sure that there's no leaks in the roof or the side walls of the bins. We don't have that buildup of crust on the bins. Like I said before, there's a reason those are getting all crusty and nasty. Try to find those issues and fix them before you fill the bin back up with grain. Also, if there's rusted areas, you want to check those areas, make sure they're still sturdy, and then also continually fix those areas to prevent rust from occurring. Probably the most important aspect is you want to make sure you have proper fan operation in your larger grain bins that have aeration systems. Make sure those are working before you refill them with loads of grain, and just continually monitor for any other signs of moisture, whether that be a leaky roof, leaky man doors, things of that nature. So once we have all that taken care of, we got our samples and our tests ran, and we got our bins cleaned out, you're still not home free. You can definitely create problems in your grain bins or inside your feed mill in storage if it's mismanaged. It's actually a very high possibility to mismanage grain inside of storage, and I'll show you an example of that later on before we end the presentation here. Just know that grain bins are kind of a perfect environment for mold growth. So having those proper aeration systems and being on top of that kind of thing is extremely important. And I always say that a detailed monitoring program is essential to prevent mycotoxins or other quality issues inside of the mill or the grain bins. So once you have that grain inside the bins, your job does not stop there. You need to start monitoring those grain bins for moisture, foreign material, warm weather. Start looking for pests around your grain bins, and also be aware of changing in seasonal temperatures. So what do I mean by all that? Well, what I would recommend doing, what we've had success in the past, is we take multiple grain samples when we're filling the bins, and then also taking multiple grain samples when we're storing that grain. It can help account for variable in moisture and reduce the risk of storage molds. And then based on those sample results that we get inside the bin as we're storing those grains, then we manage our aeration fans accordingly. But just remember that aeration fans is used to cool grain in the fall and help warm it up in the spring. Never try to use fans to actually physically dry grain. If you're going to need to dry grain for storage, you need to have a dryer, a proper dryer. Some other kind of tips or pointers for grain storage is that you should cool the grain slowly, like 10 to 30 degrees Fahrenheit increments for winter storage. It makes it less subject to mold growth if it's cooled slowly. And no matter what time of year, try to keep that grain maintained within 15 to 20 degrees Fahrenheit of the average monthly temperature. And that was not happening in a case that I ran into, which we'll talk about here in just a second. For grain storage, I like to show everybody this. Not all feed mills are going to have grain storage for a year. Most of them aren't, but this is still a really good graph to show everybody how this particular chart is for corn, but how most grains will react to different temperature and moisture levels. And the story of this chart really is that the lower the moisture levels of your grains and the lower the temperature of your grains, the better off you're going to be in storage. When you start to get to that 18 to 20% moisture levels, that's when you can really see some issues inside of grain bins. Same with your temperatures. The higher the temperatures get, the more likely you can potentially have issues. Now, you may be thinking like, that seems unrealistic that that would happen to my grain bin. Well, that's what we thought too. At a previous company I worked for, I was director of quality there, and we had a feed mill down in the southeast portion of the United States. And one winter we were having some production issues at a farm that we fed, and the CEO, which was my boss, was he suspected something was going on at the feed mill, and he sent me and one of my coworkers down there to investigate. And we drove down to the feed mill. We pulled into the parking lot, and this particular grain bin was a 500,000 bushel grain bin, which is a ginormous storage bin. And it had about 250,000 bushels of corn in it. So it was about half full. And when we pulled in, the bin actually looked like it was smoking. Like out of the vents on the side of the bin, you can imagine there was like smoke coming out of it, and it's caused a pretty big concern, right? We thought maybe there was a fire inside or something. So we climbed up real quick to the top of the bin, and we opened the man door. And when we opened the man door, the inside of the door was just covered in white and pink mold. And we looked down into the bin, and this is kind of the view we saw. And let me get my pointer up here. I don't know if you guys can see this. It's not the best picture. Obviously, it's in a dark grain bin, but all this right here is this white mold that was covered the entire 250,000 bushels of corn. And then there was a black mold in between the white mold. It was just a humongous mess. Now, how did we get to this point in this particular grain bin? Well, it was essentially some negligence on the feed mill manager's part. He had received in some loads of grain, quite a few loads of grain off the rail that was very high in moisture, way higher than what we wanted to receive in. He went ahead and received them in, put them in this grain bin. On top of it being wet outside, the temperature that winter down in the southeast was unseasonably warm. It was around 80 to 85 degrees Fahrenheit for a couple months. So this grain ended up getting up to about 80 degrees Fahrenheit. Well, then a month prior to us getting there, they had a cold snap where it got down very cold, in the 15 to 25 degree Fahrenheit temperatures, and stayed that way for a week or more. Well, that grain, the aeration fans were never turned on. The grain at that 80 degrees Fahrenheit met that cold air outside that was 20 degrees Fahrenheit, and those mixed and created condensation in this bin and essentially raised the moisture levels in this bin greatly, causing mold growth to the extreme level. So essentially we did a horrible thing in this scenario where we ruined a large portion of the grain at this facility. So we don't want this to happen. So in conclusion, to prevent something like that from happening at your feed mill, make sure you have a plan whenever you are receiving in grain. Make sure you have that trusted supplier bringing grain that's going to be inside your parameters and your expectations. Make sure you have the operations to take a proper sample, and if you don't, make sure you're working to get those proper pieces of equipment. Make sure you're testing for the your moisture, your foreign material, and mycotoxins if necessary. And then we got to make sure we're properly storing our grain. All right, if you guys have any questions, I think at the end of the webinar we can get to those.
For sure. Thanks, Josh, for getting us started today. You always give us a good reminder of the importance of proactive preparation when it comes to getting a facility ready for the intake of raw materials. Next up is John Winchell, who's going to talk about the use of technology and data in mycotoxin control. Being a self-confessed lover of mycotoxins, John always brings a huge sense of enthusiasm and knowledge to the topic of mycotoxins, and I'm certain today will be no different. John, I know you've had a busy few weeks crisscrossing the USA, so thank you for taking the time to join us at the workshop today.
Well, thank you, Martin. I appreciate you having me, and there we go. Hopefully you can see everything well.
We can indeed, and we can hear you loud and clear. Thanks, John.
Beautiful. Well, thank you. Yes, I do love my mycotoxins, which sounds really strange, but I guess it's probably appropriate for my talk today. So what I'm going to talk about today is utilizing data at the feed mill, and I could probably, not necessarily myself, but probably Josh could talk about the data that feed mills use. And I've been working in the dairy industry, but working in conjunction with feed mills for probably about 25 years now, and I've seen a lot of things at different feed mills, but we've come so far with all the different data and the way we can track things and the way we can use analytics to track data, both from a production efficiency level and other levels. Today, I'm really more going to focus on the mycotoxin part of that equation, because we could, like I said, we could have a whole feed production meeting about all the data and all the efficiency and the analytics that we have. So we will get going on this side of things. So food safety is probably at its highest peak for consumer interest and producer interest. And there's just so much, and with social media and everything else, there's so much involved in food safety now, and the awareness that the consumer and the producer has is probably farther than it's ever been. So with that being the case, usually when you look at this picture to the bottom right, if we're looking and trying to be concerned about food safety at that point, we're probably a little bit late, because obviously it's already in the bins. We can take a look at the testing part, and we're getting closer, because then we can at least see what we're testing for, and that's a good start. There's a lot of feed mills that have them, And then there's also a lot of feed mills that are working on setting those up. And I can't tell you how many mills I've set up over the last couple of years with a mycotoxin management protocol system. And we're getting more and more and more. And as food safety and consumer demand demands that, I think that's very important. But I think it often starts and ultimately starts at feed drop. To me, that's one of the most important parts, to tie that as well as mycotoxin testing together. So when we look at this, that's one of the questions I've always received is we've, never had this amount of mycotoxins before. We've never had this amount of interest and questions on mycotoxins. And I think there's a few reasons for that. Obviously, one of the biggest reasons is the ability of how we can test and how sensitive our testing is now compared to what it was in the past. Plus, it's the whole idea of a lot of these factors with increasing global temperatures, elevated CO2. We have more extreme weather events. I guess I won't say as much drought stress, but more extremes on the weather side. And, one thing to remember about the mycotoxin side really quick is that when we're droughty, we can have certain mycotoxins and have certain signatures for certain mycotoxins. If we're wetter and cooler, we're going to have different types of issues for mycotoxins. And we've done a great job with our agricultural practices, and we're trying to get better with what we're doing with that. But still, at the end of the day, there are times when we are at the mercy of Mother Nature, but we have to make sure we're cognizant of what we're doing with this, and it can be frustrating at times. So what are some of the things that we can do? And I know this is a feed mill management and production webinar, so I'm not going to spend much time, but there's a lot of things that can be maintained and worked on to mitigate the risk of mycotoxins from our producers and our grain suppliers, from the planting and the harvesting, the crop development, crop management, harvest management side. But then when it comes to what we're talking about today with crop storage and feed manufacturing, and ultimately the end user being the animal, and then obviously when we follow through that as well to the human side, these are really important parts that we can do. And Josh has touched on a lot of these different things here earlier so eloquently at some of the ways that we can test and we can monitor and we can manage these individual situations. So when we get to this point in time, we're probably too late. It's already in the bin. Many people are cutting streams to monitor mycotoxins as a way to kind of double ensure that they're keeping that risk down and being able to manage those situations correctly. But when we look at different situations, we need to have some protocols in place. We need to test. We need to have an action plan, whether it's corporate feed companies, large poultry integrators, large hog integrators. We need to have these internal operating procedures in place and these protocols. And then there's also industry protocols that we need to be cognizant and aware of. And then there's national and regulatory regulations that we need to monitor as well, because with in the US here with FSMA and FDA, there are certainly different regulations that we need to work on. So when we get the data, one of the biggest things that I work with when I start working with some of these customers is they're doing mycotoxin testing routinely of different commodities and some finished feeds. And they typically just take the test and they get the results, and they either log it in a book or a binder, or they put it in Excel and they watch to see the results of what they do with that information. But to me, I think what's really important is they get this information and they're able to tell right away if they have high risk or low risk grains. But then what do we do with that data from there? And that's where I think some of the work that Alltech Mycotoxin Management team has done with the RapiRead program, and we'll talk about this through the rest of the presentation. This is really very, very crucial and very critical, and a great step and an industry leading step forward. So what do we do with the data? So what we've done is we've designed the Alltech RapiRead platform. And what it is doing, it is taking that information that we get out of the mycotoxin test, which if you look to the right here, you will have a Neogen Raptor, which has been out for 4 or 5 years, tests for multiple mycotoxins. And it is a really accurate, really one of the industry leaders when it comes to these rapid test kits that we're going to have at the mill. Because one of the worst things we can do is test grain loads or finish feeds for mycotoxins. And if we send them off for some tandem mass spec, that's great information, but oftentimes it's a 7 to 10 day window, and we need to have this information right away. So with that being said, what I like about the Alltech RapiRead is what we're doing is we're turbocharging or supercharging this data. We're taking the data that has already been generated from those individual tests, and then we're taking that data and molding it almost into a sculpture, because we're taking that data and we're able to kind of take that and look at the analytics and track. And really the goal with Alltech on our Mycotoxin Manager platform is to identify the risk and quantify the risk and ultimately mitigate the risk so we have a cleaner feed source for our animals and ultimately on the people side as well. So what I love about the RapiRead program that we have is we have taken that data and harnessed it and are putting it to the full breadth of what it needs to be, similar to, you know, analytics in different sports or in any walk of life. There's so much analytics now, and that can be good and it can be confusing, but I think what we've done is tried to make it as simple as we could. When I go back to look at different mycotoxins, I'm asked this question very often. Probably the most often asked question is, what mycotoxins do we test for? And a lot of times I will say that depends. If we're living in the US, we are FDA mandated by aflatoxin, deoxynivalenol or DON or vomitoxin, and fumonisin. So oftentimes, this part of FSMA or FDA, we are often required to test for aflatoxin, DON, and fumonisin. There are other mycotoxins that the Raptor from Neogen will be able to test, and some of the other rapid test kits will be able to test all of these as well. Aflatoxin, DON, T2, HT2, zearalenone, ochratoxin, fumonisin, and there are some ergotoxin tests that are coming, that are on the market. But these are really the 6 different ones, and I would say that primarily the big 3 are pretty accurate to test for, but it depends on the species. If you have certain niche species, you might want to look at zearalenone if you have a lot of breeding stock, or you have, say some show pigs or some stock that were primarily going to be used for a lot of breeding sources. So that would be an important part of it as well. Though they're not FDA mandated, we are pretty good for that. So what we do is we've taken and created a way where we can take that information from the rapid test kit and from the Raptor and pull that data out and be able to mold that data, like I said earlier. So what we do, it's really not much of an addition to what we're doing already with testing, because the last thing we want to do at the mill level is going through these steps and then have to add a bunch of steps to it, and then it just creates a little more work and more time, and none of us have more work or want to have more time. So what we do is, one of the most important parts of this is whether you're using a iPhone or an Android or a tablet or an iPad, and we actually have created an app that you can use, and then you can go through and you have a test request that you can put together. You can put in the town, you can put the title of what the of what the sample is, whether it's corn from a certain supplier. You can put a date code in that title. We can also select for species and then production group within that subspecies, because we know with a lot of the work that we've done for different species, whether it's breeders on the poultry side, breeders and broilers and layers, there are different mycotoxin thresholds and risk thresholds and performance thresholds that we're going to run into. So this is a first step. It lines everything up. It puts the location of the grain, It puts a title to the grain of who the supplier is or where it's coming from. We have the species, we have the production group, and then finally, we can go in and select for the individual ingredients that we're utilizing for the test. Once we've accepted that, it will instantly create a QR code. And we take that QR code, and then when we're running a sample, for example, on the picture to the right with the raptor, you have the option to either type in individually the name of the sample, or you can scan a QR code. And the beauty of this is since you already have put all of this information in to your phone app or your iPad to create this QR code, that will automatically generate that and put this up into a cloud. So when you think of when you first just type a sample into your rapid test kit, you're just typically putting in the name of a sample, or in a lot of the ELISA cases, 1, 2, 3, 4, 5, 6, and then you have to go back and line those back up and put them into a spreadsheet. So this really does all of that for you. And the beauty of this also is if you're testing for multiple mycotoxins per sample, you can just utilize this QR code and scan it 3 different times if you're checking for 3 different mycotoxins. So you don't have to go through the laborious process of typing this in over and over again. So to me, this is a huge advantage and a time saver, even though initially you might think it takes more time, but actually it saves time when you're checking for multiple mycotoxins. And then the other part of this on the back end is once we have the data and once we've already taken the samples and have the sample results, all we do is we will just take and put the in this case, the raptor in the USB mode. And then we have a data sync tool on the computer that we just transfer the information from the raptor onto the computer. And if you have a Wi-Fi enabled and a mycotoxin portal for Alltech Mycotoxin Management, it will just put that right up into the cloud. And to me, this is a great addition because automatically, simultaneously, you have this information. And as we go, when we look at some of these large poultry integrators, some of these feed mills that have many locations, we can actually set up a rapid test kit, or in this case, a raptor at multiple locations. And then we have these separate accounts. All these mills have their own testing system. And then we have a master account over top of that all goes into the cloud. So all of these different feed mills and feed locations can sample their mycotoxins, put this up into the cloud with the data sync tool, and it will automatically go into this master account where they can select by multiple locations, and they can also have access to some of the admins, some of the quality assurance or quality control people, the nutritionists. Anybody that is pertinent will be on this master account, so they can monitor these locations and these mycotoxin levels at different locations. And then they can also take that data and look at it all together as a total unit. And this is an example, I pulled this off yesterday. This is an example of deoxynivalenol from 2021 to 2023. And these are different levels of vomitoxin or DON done by the rapid test kit throughout the world. So when we go onto our mycotoxin management portal, we take this information and we have our samples analyzed. We can see that right away. As soon as we put in the information and a query, we can set that up, whether it's by individual feed mill or look at it as a total. We can also go in and set this up you can select for different commodities or finished feeds or whatever we're trying to look at. So you can segregate it by feed matrix, so whether it's corn or different commodities, or you can set it up by location, and then it will show you how many on the data summary. It'll show you how many samples were analyzed. It'll show you mycotoxin tests, and it will show you all of this information. You can look at averages and maximums, and you can look over to the right. That's where you're going to get an REQ when you see that risk equivalent that you're going to see, and it will show that risk level, and then it'll show what percentages of the feeds are at lower, moderate, or high risk. You can also go into this same portal and you're able to look at these individual samples. And I like that because I like to go back and where you have the ability to go back and track this data. So you can look at For example, here is what is one of the locations that we work with. And then the beauty of this is you can go in over to generate report, which is all the way to the right in the orange letters. And you can go in and take, if you want to have broilers or poultry starter or breeders or layers or turkeys, you can generate a report. And knowing that every species has a species or production group has a different threshold for risk with mycotoxins, you can go in and generate a report, and it'll give that different risk for each one of those species and each one of those production groups. And then if you also want to have a result, this is one of the results that you have here off to the left. And then you can also, on that phone app or iPad, you have the ability to go in and look at that. As soon as that sample is uploaded into the cloud, you will have access to that in the field or at the mill or anywhere externally as well. So what does this mean? What does the data tell you? So I have many different feed mills that I work with. And some of the issues that I work with, it's interesting taking that data, and not everyone has a chance or has the expertise of using the Mycotoxin Manager portal. So I like to work with these mills and start to say, okay, for example, this scenario right here, this is corn DON suppliers from 2020 to 2022. So there are 8 different suppliers, and this is the individual DON level and the averages from 2020 to 2022 of your different suppliers and the average DON levels of these suppliers. So this will tell you a lot, and you're able to vet out some of these opportunities and start to monitor this a little bit as well. And then, obviously, as the DON level goes down, especially if you're on the swine side, because we have a low DON level for finished feeds, you want to focus on the suppliers that have that lower DON level. This is another supplier that we looked at this information, and they were getting, in this example, corn gluten feed. And we were looking at 4 different suppliers, and we were able to vet out one supplier for, actually it says 2022 to 22, but it was 2020 to 2022. And we could see that we were getting some high samples, and they were aware of some high samples. But then once we started to take that analytics and take the data and track it, we found that it was really one supplier where they were getting the majority of their high samples. So if we want to work on a clean food source and some food source or a commodity that's going to maximize production, we want to focus on that. And this is where, to me, the beauty of the RapiRead system really, really jumps into it. And then when you look at different feedstuff comparisons, there are some comparisons where you're looking at different cost structures, whether corn might be at a high cost point when you can look at maybe substituting hominy or wheat or in different situations. But in this individual situation, you can look at corn, and then you can look at hominy, and maybe hominy might have been a very good buy. But if you look at checking through the data, actually hominy had a higher mycotoxin or a DON level than what we had in fumonisin as well compared to the corn. So even though the corn might be a little higher in cost, we might have less animal issues by looking at that. And that's part of this analytic package that we're looking at. Also, if you're on this system for a long period of time, you have the ability to go back in and look by whatever mycotoxin that you tested for, whether in this scenario, DON, zearalenone, and T2, you have the ability to look at it over time and see where the hot spots and what historical patterns we have with that. And then you can also take a look at the same thing, whether you're looking at low risk, moderate risk, or high risk. So, and then if you have multiple locations or you're getting commodities from multiple locations, you have the ability, if you're putting in the supplier or the town of where you're getting the ingredients from, you can take a look, and you can, as you can see on this chart, which are all included in the mycotoxin portal, you've got AFLA, ochratoxin, deoxynivalenol, T2, fumonisin, zearalenone, ergot, and then we have the REQ. You can look at all of these different mycotoxins depending on if you have tested for them or not, and you can actually look at and see where your hot spots and where your risks are. I work with a feed company in Canada. We do that all the time, where we're looking for where we're getting corn coming from different hot spots, or whether the grain is on the good side. And you can also look at this other map that will show where you're having issues, where if you look at aflatoxin in the Northeast, very low risk, zearalenone for the most part low risk, but deoxynivalenol will shine and have a little more risks in different areas. And this is probably the best example that I can give of a feed mill that has actually done a super job. They've been using the Rappy Reed and using the Raptor since we started the program a few years ago, and they have probably done the best job with it because they've taken that data, they've taken it, put it in by supplier, and put it in by location. And if you look here on the graph, from 01 to 21 to 01 to 23, look at the deoxynivalenol and how that number has dropped as they've gone and tried to vet out and manage these suppliers. To me, this is the key to what we're trying to do. We're trying to make a cleaner food source, and this is probably the best shiny example that I've seen of this because they've done an outstanding job with doing this. And if you have any other questions, I'd be happy to answer it. And thank you for your time, and I'm honored to be part of this feed production webinar.
John, thank you for sharing that. With mycotoxins becoming a very important topic in the area of feed production, it's always good to hear about the advancements in the technologies available to control the challenge. Our next speaker is Saurabh Malhotra, who is a global product manager for optical sorting at Bühler SORTEX. As a company, Bühler Group are at the cutting edge of using technology such as artificial intelligence and machine learning in grain sorting equipment. Saurabh, we're very excited to have you with us today to share the latest developments in this sector.
Thank you very much. Can you all see the screen?
We can see the screen and hear you, Saurabh. So yeah, please go ahead.
Welcome, thank you. Welcome everyone. My name is Saurabh. I'm from Bühler Group, and what to expect in the next 20 minutes. I'm going to quickly run through Bühler Group at a glance, main challenges for feed processors, and then we talk a little bit about our technology and how its application in the feed industry. So let's get started. It's Bühler Group. Let's start a few words about the parent company. It's a Swiss family-owned company. We generate about 3 billion Swiss franc turnover every year. We operate in 140 countries, and overall, the family has 163 years of successful business operations in food safety and food-related products. Innovation is at the core of Bühler. With over 30 manufacturing sites, and 12,700 people, we develop technologies which help a lot of people around the world. Billions of people come into contact with technologies. Sorry, just a second. Billions of people come into contact with Bühler technologies to cover the basic needs of food, mobility every day. For this, we develop the best process solutions along with complete value chains. For instance, 2 billion people enjoy food produced on Bühler equipment, and about further 1 billion people travel on vehicles manufactured with parts produced with our machinery. Having this global relevance means we also invest heavily in our R&D infrastructure as well. Around 5% of our turnover is invested back into developing technologies to reduce waste, energy, and water for our customer value chains. Around 91 sales offices around the world and around 105 service stations. Now you know a little bit about Bühler. Let's have a look at the optical sorting side of Bühler.
We are Bühler UK. We are dedicated to the development and production of optical sorting solutions. Welcome to our headquarters in East London Docklands. We have further production sites in Brazil and China. We are proud to be part of Bühler Group with a network of 32 factories globally. Inside our factories, we work with multiple standards that are a key part of our culture as they ensure quality and safety in both products and services in international trade. Our goal is to build machines that last the test of time. From design to shipping, we take great care in every step of the process. Our R&D and manufacturing are highly integrated because only if we have control over each step, we can guarantee performance and quality. Over the years, we have been early adopters of numerous novelties to improve our manufacturing process and participate in circular economy. All the machines are modular, making them easy to update and upgrade. We expect them to run for many years and stay up to date with technology. Inside of our machines, state-of-the-art camera technologies work together to eliminate all foreign material and all defects to only let the top quality product through. The camera systems are the heart of our sorters, and we take great care in the camera assembly. Our in-house cleanroom systems can adjust the optical elements at an accuracy better than 1/2000th the width of a human hair. We have a complex and innovative product range of 40 different machine types with an average of 3,500 components inside. We offer sorting solutions for over 100 different product commodities. Our sorters undergo rigorous environmental and temperature testing before shipment. We even got certified to ship our machines directly from the factory onto the aircraft to cut down on delivery lead times for our customers. Bühler UK is built on a strong lean manufacturing and continuous improvement culture. Safety, quality, cost, delivery, and people. All of it comes together to give you a machine that performs as well in 10 years as it does today. We proudly stand behind our satisfied customers and our optical sorters.
So now we've seen a short video about optical sorting. Let's have a look at the commodities we handle. So we do everything from rice all the way to pet food. And here, specifically for feed, let's look at some of the challenges that happen. A big trend in the industry is the so-called pre-immunization of pet food. This has started before the pandemic, but it's accelerated recently. The pre-immunization has created many growth opportunities for producers, but expectation from customers are rising again. Customers paying for premium products are less likely to accept foreign material and different type of kibbles alongside the kibbles. Many ingredients, and particularly animal protein, are byproducts of the meat industry. Those byproducts are often contaminated with plastic, and so on and so forth. SORTEX F is the answer for that. But if we look at feed for corn and wheat, the biggest challenges we see are in the in-feed and intake stage. The aflatoxin, DON, defects on cross-contamination and foreign material. For these, we have two technologies we will focus on, the SORTEX A LumaVision and the SORTEX H SpectraVision. So what problems should be solved? When we talk about wheat and rye, the biggest challenge is DON reduction in wheat and in rye, ergot removal, which is also related to toxins. So, and foreign material as well. For maize, aflatoxin reduction in maize, corn, diseased grains and damaged grains is the big topic. Barley, cracked kernels, fusarium, affected grains, pink mold, stones, split hollow kernels, black seeds, DON and black moldy beans as well. For oats, barley, soft wheat, rye, discolored wild oats and rice. LumaVision. Our LumaVision technology is designed for detecting aflatoxin in the maize. The way it works is we shine a high UV lighting on the machine, and we see some products are glowing blue and some are glowing green. The diseased grains are green in color, and they are showing signs of aflatoxin. When we measure aflatoxin, why is it important to check every single grain? One of the major issues that Josh mentioned earlier is sampling at the early stages. You know, aflatoxin in maize through the food chain is a problem of analysis and sampling. Aflatoxin tends to appear at hotspots throughout the bulk of the product. In a typical truck, we can see that it would be quite easy to pick samples of either high contamination or low contamination. So a good sampling is really a good starting point. But it's often said, if a truck is found to be contaminated, just drive it around the corner on a block and try again. Just a few grains with high contamination per kilo could cause a complete bulk of the product to be contaminated, and then it's not suitable for the mill anymore. How can Bühler help solve that challenge when we have higher levels of toxins in our product streams? You see on the picture on the left-hand side, the The toxin is not visible on the grain, so the primary accept and the primary reject on our machines look identical. We should put it through the UV lighting and you start to see the differences. The diseased grains are glowing in a slightly different color. And what we see, our efficiency figures are higher, the higher the input contamination. So for input contamination of over 100 parts per billion, our reduction efficiency of aflatoxin is about 90%. From 26 to 100 parts per billion input contamination, our reduction efficiency drops a little bit to 80%. But then when you're talking about under 10 parts per billion, then the efficiency drops because it's about measuring such a small sample. And it's quite difficult and challenging to really eliminate down to zero. Yeah, so it's about reduction and not complete elimination. The higher the input contamination, we can reduce it by a really high efficiency. It's not just aflatoxin that our machines can remove. When we do testing on the rejects from our LumaVision machines on maize, what we see, we are rejecting film, DON, ZON, as well as aflatoxin. So it's the reject that you see in there is highly concentrated. It's also removing other defects that also exist in the input stream. So LumaVision, it's a completely new approach to optical sorting. It removes fluorescent defects, which are diseased grains on aflatoxin or diseased grains by aflatoxin. It can process up to 20 tons per hour. It's available in flexible sizing, 3 to 5 modules, and Industry 4.0 ready. So you get data analytics from the machine through a dashboard. So you can see exactly what the machine has produced at what time. And you can also look back in time and look for an input sample from a different supplier, for instance. So to summarize, the LumaVision technology can help you reduce aflatoxin by up to 90%. We've reduced the risk of return product and product recalls. With this, aflatoxin monitoring means that every single grain is inspected, and you reduce the risk of missing hotspots on aflatoxin in the product load, giving you the peace of mind. So it's not just a case of knowing that we have a product which is contaminated, but then taking action. And this machine can help you take that decisive action to remove the diseased grains and manage your supply chain. Now, let's have a look at a second machine, which is SORTEX H. This answers some of the difficult challenges when it comes to DON and removing the DON reduction in wheat and ergot in barley. So to summarize, this is a brand new machine that's come out very recently, and it's targeting high capacity color and foreign material sort on grains. Nothing goes unseen. It's equipped with full color cameras and enhanced in-gas technology, which can see some of the defects which are not visible in the visible spectrum. It's available in 1 to 7 modules. It can process up to 8 tons an hour per module. Best reject concentration, minimizing resort and waste. And it's Industry 4.0 compliant as well. So let's look at some of the examples of its application in the grain feeding industry. So primary application is DON reduction. So here you can see the input contamination is around 5.8 parts per million, and we reduce it down to 1.7 parts per million. And in the reject, when we measure, it's around the 40 parts per million DON on average. When we look at ergot removal, you can clearly see that the reject is highly concentrated with ergot. It's easy to sort, typically 99% reduction, good product reject, relatively low loss of yield, about 1%. Some other commodity examples are corn. In an example that I gave you about LumoVision, where we can remove aflatoxin and the moldy grains, foreign bodies, damaged grains, diseased grains, and also at higher capacities as well. So around about 62,000 tons per hour, 62,000 pounds per hour, or 28 tons per hour. Barley, here the Fusarium infection is really common. It's basically the pink mold or black seeds as well. And so typically we would remove all of these different color defects and also the toxin defects as well, all at 15.4 tons an hour or 33,000 pounds per hour. For oats, we focus on soft wheat, barley, rye, wild oats, mud balls, and discolored stuff. So that's at 2.2 tons an hour or 48,000 pounds per hour per shoot. The total max capacity for SORTEX H is 15.4 tons an hour for this application and 33,000 pounds per hour. So what I would like to invite you guys is to start a bilateral call. Perhaps you can take our details, and if you have further questions or further inquiries, feel free to get in touch with Stephen Jacobs, our global head of segment for feed, or myself. We're at your disposal. And then I'll pass the floor back to Martin.
Thank you, Saurabh. We certainly will have some questions for you at the end of this. I think it's an exciting new area, this type of technology, and I guess the level of precision that it can bring to ingredient handling is one of the big opportunities it's gonna take to the feed sector. To finish our formal presentation today, we're going to welcome back Josh Teulker, who's going to share with us some best practices when it comes to designing a quality control program at the feed mill. Josh, I think you started your career in the agricultural industry working on these programs, so you do bring a pretty unique perspective to the topic.
Yeah, I'm a lot of cool stuff over there at Bühler going on. I'm excited to hear the Q&A at the end of this webinar. Yeah, I'm going to talk about, as Martin said, how to properly design and implement a quality program at a feed mill. So all kinds of exciting stuff in this presentation, but I think it'll be extremely helpful for anybody looking to improve their quality, not necessarily just make a new quality program, but continually improving what you already have. So something I kind of wanted to mention before we started, and I kind of want you to keep this in the back of your head when you're working on your quality program, is something that one of our founding fathers here in the United States said is an ounce of prevention is worth a pound of cure. And that's something that is sometimes hard to fathom when you're working day to day at a feed mill, but it's 100% true in our feed milling industry. If you can create a quality program that's going to prevent problems in the future, that's always a better option than trying to cut corners during the day-to-day grind at a feed mill. It's not always the easiest thing to do, but it's oftentimes the right thing to do. So keep that in mind when creating your quality program or implementing it into a new facility. So let's talk about why we should have a quality program in the first place. It really provides us with a lot of things and a lot of opportunities. Good quality design in your feed mill will always increase performance at your feed mill. It'll create more reliability to your customers, and also you will become more of a durable feed mill for your customers. You'll be that tried and true feed mill that always produces good quality feed, which is a great reputation to have. The aesthetics of your feed will look better to your customers, which is extremely important. The conformance will be much easier to abide by when we're talking about governmental regulations that are put down on your feed mill. Those seem to be ever changing. So it'll be much easier to conform to those if you already have a proper quality program. Something else that it really helps with is if you have new supplier audits coming to your feed mill, or third-party audits that you're going to have to abide by, having a good quality program makes those processes much more efficient. Also, it'll make your feed mill safer for your employees and also for the customers that you're feeding. And having a good quality program will perceive you to be a good quality feed mill, which is always a good thing when it comes to obtaining new customers and your reputation in the feed industry. Okay, put this slide up here. Great big bold letters is keep it simple at a feed mill. There's been more times than I can remember where you go to a feed mill and maybe a feed mill had hired someone, from the food industry or the pharmaceutical industry, and they go to a feed mill and they kind of freak out, for lack of a better term. And there's dust. It's a feed mill. It's not good. It's not safe. Those are all things that we deal with in the feed mill, right? And the biggest thing you could do is try to simplify everything in your quality program, at the same time making it adequate for controlling quality. So keep that in mind when you're building your quality program. Is keep it simple. So, what are consequences of poor quality in your feed mill? There's a lot of them, many of them, in fact. Loss of business is a big one. Obviously, if you continually have poor quality, customers are not going to want to come to you anymore for their feed. You have some liability issues that you could run into if the quality of your feed is so poor that you end up harming some of your customers' species or animals that you're feeding. You can also lose productivity if you're having feed returned or recalled on a regular basis. That's not good for productivity. And finally, it can be horrible for cost. I will say this, that a quality program will probably cost your feed mill some money, but the money you spend on a quality feed program will greatly outweigh the cost of having poor quality feed, whether that be loss in revenue from customers leaving you, or recalls or things of that nature. So how do we start a feed quality program? I think the biggest thing you can do is start asking all kinds of questions. When, what, where, why, how. All these questions need to be asked in every step of the way at a feed mill. How are we going to implement a quality program? Why do we even need a quality program? What are we going to do to increase the quality of our feed? These things need to be answered, and I would recommend, to answer these, you get the front line of the feed mill involved. I was a director of quality at a large layer producer here in the U.S., and you have to admit to yourself that you don't know as much as these men and women working inside the feed mill every day as they do. They're the ones that are involved in the feed mill. They're running the mixer every day. They're processing the feed every day. They're receiving grain in every day. They're the ones that really know what's going on in the feed mill. And to keep them involved will make your life much more simple. When it comes to a quality manager, they'll be more on board with making changes if they're involved and they understand where you're coming from as a quality manager at a feed mill. and it just goes smoother in general. So definitely make sure you're keeping that front line of the feed mill involved in those employees that work at the feed mill. Okay, so now let's actually build a quality program in your mill. I'm sure many of you have heard of HACCP before. Many of our government body regulations use HACCP as the cornerstone of their regulations, and I think it's a great tool to use to build your own quality program at your feed mill. The first thing you're going to do is create a hazard analysis at your feed mill. We'll go over all these steps in the future of this PowerPoint. We're going to identify what are some critical control points and control points at your mill at each step of the way. We're going to establish critical limits at those control points. What can we accept as a limit to those issues we're having at the feed mill? We're going to figure out how we're going to monitor those processes or those procedures. If we have problems, we got to know what the corrective actions are for each of those steps. We got to verify that these procedures we put in place to monitor these control points are working. And then everybody's favorite, at the end, you have to have paperwork and records to show that you're following these protocols. So how do you conduct a hazard analysis? And what I'm going to do, everybody, is I'm just going to run through an entire example of how I would run through a hazard analysis for a particular area in the feed mill. But to start off, what I would do is I would break down your feed mill from start to finish, from your suppliers at the beginning all the way to your delivery trucks going out to your customers or wherever your process ends at your feed mill. And I would write down every single step of that process. And then underneath that, each step, I would write down what the risk of each of those processes are, whether that be a biological, chemical, or physical risk. Write those down. And then once you have every single risk that you can think of, and when I say every single risk, a realistic risk, you don't have to write down that there's a chance that a UFO will come in and abduct our feed mill. Like, that's not a realistic risk to write down. So make sure you're writing things that are realistic and probable to happen. You don't have to go. You can put your mind in a pretzel thinking about everything that could go wrong. So make sure you're writing down probable risk, and then what are the likelihood of those risks occurring, each one, and kind of order them, make them put them in an order from most likely to happen to least likely to happen, and also kind of give them a grade on what the danger is of each risk. How severe can these risks be? Because I'll give you an example at receiving. A little bit of foreign material in your grain is not nearly as severe as if someone unloads fertilizer in your receiving pit. Those are both hazards that come at receiving, but one is much more dangerous than the other. So that's kind of the things you got to think about in your feed mill to make sure you're covering all your aspects. So for the example I'm going to use, and kind of to keep the theme of this workshop, since we are part of the mycotoxin management team, I'm just going to use mycotoxins as our example when you're creating a quality program. Let's say you identify at receiving that DON could be an issue. Let's say that you think that maybe 5 ppm of DON could be an issue for swine coming into your feed mill. So once you have that, that in your mind, that is an issue, we can identify that as a control point we need to address in our quality program. There's also another term that is often used in the HACCP world, or even in the feed mill industry, and that's critical control points. There is a difference between control points and critical control points. And it's very hard to kind of define those in a feed mill. We don't have very many critical control points in the feed mill, in my own opinion, to where it can be extremely detrimental to the species we are feeding. But there are some. Just some examples I could think of is, like, if you're bringing, grain in from a area that is infested with avian influenza and you're feeding poultry. Like that's a critical control point that needs to be taken care of immediately. That's something that is very serious. If your feed mill is a carrier of that, that to your customers, it's going to be very bad for your feed mill. So think about those very critical ones and make sure you have a good plan. In this case would be some biosecurity to combat those type of critical control points. It's essentially, they're essential to prevent or eliminate a food or feed safety hazard and to reduce them to an acceptable level. Okay, but let's go back to our example of Dawn coming into our feed mill. Let's say we established that by reaching out to, let's say, Dr. Max Hawkins at Alltech, that we can accept up to 5 ppm of Dawn in our grain to safely feed that to pigs. And that's just an arbitrary number. That's actually the limit here in the US via the FDA. But we found this out through Alltech, and we decided that since we cannot receive any grain over 5 ppm of Dawn, we decided to buy a Neogen Raptor and test every load coming into our grain, our feed mill for Dawn. Okay, so now that we know the risk that there's at receiving is Dawn, and we have a plan to monitor that risk. Next, we have to establish some type of a corrective action for that risk. And typically at a feed mill, that corrective action for loads greater than 5 ppm of Dawn is going to be that we reject that load of grain coming into our mill. It can be other things too. There could be maybe a bin that you divert that poor quality grain to later, divert it to eliminate that Dawn. Or maybe you have some type of a machine like Bühler was talking about, not necessarily for Dawn, but for aflatoxin or something along those lines. You have to have some type of a corrective action written into your quality program that shows that you've taken care of that risk of Dawn coming into your feed mill. So you've done all that. Now we got to make sure that what we are doing is actually working. So in the case of mycotoxins, maybe something you can do is take samples from the storage bins and test them on Alltech's 37 plus or whatever testing procedure you would like to do, and just ensure that what we were doing at receiving with our mycotoxin testing is properly working. And if it's not, figure out why it's not, and then make changes to your quality program. It's the best thing you can do is to continually improving your quality program. So now that we've done all that, we have to have some type of a record showing that we have followed our protocols in our quality program. And for this example, that would be that we have these mycotoxin quick reports for each load of grain coming into our feed mill. This is extremely important, especially if you are, having third-party audits. If you're having government regulation audits coming into your feed mill, this paperwork is your lifeline. That's why it's so important in any of these quality programs to have some type of a paperwork trail, and whether that be physical paper or some type of electrical way of keeping track of everything. It's extremely important. And these quick test reports would be an example of how I would monitor, or how I would show an auditor or a manager, whatever the case may be, that I have been following your quality control protocols at the feed mill. Okay, a couple more slides here. This is a template that I like to show people. I started using this back when I first got into the agriculture industry, and I really haven't found much other type of templates that I like better. This is just an SOP template that allows you to kind of show your work and write down how you can record your SOPs that you've created by doing these hazard analysis. And I like this one because for a few reasons. For one, you can make it a nice box for a title and the purpose of each SOP, which makes it very clear for new employees and auditors to see what my goal is with my quality program. Something else that's very, very important when you're documenting your quality program is to have some type of a document number, a version number, and then the date that version was updated. Why is this important? So a quality program needs to be reviewed and updated at least yearly, or when changes are made to the feed mill. And having many versions of a quality document shows me that you're continually improving your feed mill for quality assurance. If I would, if I was an auditor and I would get a feed quality binder to look through, and I saw that all your SOPs were done 15 years ago and they've never been updated, it'd be hard for me to believe that you're doing a good job at quality. Because to me, it looks like you've been neglecting it for 15 years. So having some type of a way of showing auditors or management that you are continually improving your quality procedures is extremely important. Something else I would recommend writing down in your SOPs is this who, where, and when. These boxes here are representative of each of those. That way people know exactly who is supposed to be performing these SOPs, where in this area, in the feed mill are they supposed to be performing these SOPs, and then also how often or when are they going to do that. In our case, it's going to be at the receiving employee is going to be testing for these mycotoxins at the mill receiving area, and each load of grain coming into our feed mill. And then probably one of the most important parts of this is actually this action column. And that just tells us exactly how we're going to do this. We're going to take a composite sample of grain from the truck coming into the mill, split the sample, test for Dawn, a Neogen Raptor, an Alltech Rapiread, and then reject the load if it's over 5 ppm of Dawn. This was just for an example. I would make that more clear, more detailed. Any type of little thing that you need to put in this quality program, make sure it's in these actions for those that are going to use it. Also, something that's really important is these references. If you're implementing these programs for a particular reason, this is a good place to put that here. For example, in the US, we had to have 5 ppm of Dawn and finish in our ingredients coming in or less to the feed mill. That's why I put this government protocols. It requires to do that. Also, you can put in here what kind of records that you need to keep. And for this example, we had our test results, which shows that we are abiding by these actions here. There's all kinds of different templates for quality programs here. You could even make your own by just copying this over. Okay, one more slide here, and I like to tell stories. So this is going to be a story, as you guys heard about the molded grain story on my first presentation. But I think internal audits are very important for a good quality program if they're done properly. And why I say if they're done properly, because my very first job out of university was a internal auditor for a company. I was 22 years old. And my job was essentially to walk around a large egg plant and write down everything I saw that was wrong and give that to the manager of the plant every Friday. Which whenever I, signed up for the job, that sounded pretty like a pretty nice job. Well, it ended up being that you weren't supposed to talk to any of the employees while you were doing the internal audit. You were not supposed to, tell them what you wrote down. And it really was a hard job. It created a lot of tension between myself, the internal auditor, and all the employees. And you could almost feel that they just hated that you were walking through there because they knew you were trying to find something they were doing wrong. I don't suggest taking that approach to internal auditing. Creates a lot of tension between someone that's in the plant every day and everybody else in the processing facility. So I would recommend doing internal audits, but also doing them in a manner that you know, the employees feel like they're helpful instead of you're trying to get them in trouble. You could even do something where maybe certain employees rotate these internal audits so that they learn how the quality programs work, and then actually audit each other instead of having, you know, one specific internal auditor that's at the facility at all times. It's a very, very tough juggle that is hard to satisfy everybody when you're internal auditing, but it is a very necessary approach to keeping everybody honest and continually improving quality procedures at your feed mill. So before you start doing internal audits, just think about that. Think about how you could do this in a productive way that can keep everybody on the same page and not create tension in your feed mill plant. All right, everybody, thanks for your time. And I think we're going to get to the Q&A if Martin wants to take over from here.
We are indeed, Josh. Thank you for the insight into what is one of the key first steps in ensuring we're delivering the highest quality animal feeds. So we are going to go to the Q&A. So hopefully, Chloe, we have everyone back up on screen, cameras on, and hopefully you'll be able to come off mute. Josh, we had quite a few questions coming in when you kicked off the program with the topic of grain intake. One of them initially being, how would you do a supplier approval at an elevator receiving grain from farms? John, you may want to come in on this as well if you want, but Josh, maybe you can kick off with that, please.
Yeah, that's a great question. I saw that in there, and that's one that I don't know if you'd have a particular, you know, approved supplier list for your people coming in, that like farmers are bringing in, you know, you got 100 farmers bringing in different loads of grain. What we used to do is we did have like a list of approved suppliers for people that are going to bring grain into our facility. We actually took their, you know, all their information down and had them as a new customer essentially, and then monitor that from there. Like if they bring in grain that was consistently too high in moisture or consistently too high in foreign material, we would note that and then you know, bring that up to them as time went on. But that's definitely something like that. It's different than receiving in like soybean meal or something where you have one supplier for the most part. It is something a little more challenging to make sure. I will say this: a lot of times, if you have like a farmer that came from 100 miles away and he just seems a little bit like he's trying to get out of there quick and everything, you may want to, you know, take a look at that a little harder sometimes, because that happens in the grain world.
Very good. John, I'm not sure if you have anything to add to that.
Yeah, I guess I would agree with what Josh is saying. I work with a lot of smaller feed mills that take in a lot of grain from many local farms. And what I suggest for all of these mills is to make sure that of all the different customers they're receiving loads from, to make sure they're getting in the fall, when they're getting a lot of this corn in, to make sure that they're getting samples from a lot of these customers, because we have seen situations where it seems like year after year after year after year, you have lower quality grains, whether it's coming from an appearance, cleanliness, cracked kernels, not even, irregardless of mycotoxin status. You're seeing these, you know, these individual farmers come in that are kind of on that flagged list. So they kind of keep that in mind. And that's one of the best ways I think we can do to vet out some of the potential issues.
Andrew has a nice follow-on question, I think, to this. And in some cases, the feed mill must unfortunately receive grain that is not always of the highest quality for various reasons. He is asking, is there any different method or treatment in taking the samples, firstly, and then any treatment we can recommend to the customer to solve this issue?
You want me to take that one, I guess?
Go ahead, Josh.
As far as sampling goes, I wouldn't recommend taking any different type of sample. You know, whether you have a high quality grain or a low quality grain, you still need to follow specific sampling protocols. And, just to, I guess, go over that real quick, when you're taking like a probe off of a grain truck, you want to take multiple probes per truck, and we usually recommend about 10 probes per truck. And that will give you a very good representation of that entire load. Obviously, those need to be kind of split up in the truck evenly. As far as something you could recommend to your customer or your suppliers coming into your feed mill, that's really tough. The best thing you could do is just let them know that you're not happy with what you're receiving in, and hopefully they can make changes. The equipment that farmers have now is very efficient and very accurate. Sometimes they can get in a hurry and things aren't, the quality of their ingredients coming in can be real poor. And if it's okay, Martin, I'll tell you a story about what we did at one of my former employees that's kind of related to this. So we used to get some bean meal in some of our feed mills, quite a bit of bean meal. It was a very large egg producer. And we had we suspected that they were bringing us soybean meal that the protein levels were lower than what they guaranteed. Let's say that, they guaranteed 48% protein and they were coming in at 44, 45, stuff like that. We actually ended up buying a NIR machine that would test our protein levels every load. And we made an agreement with the supplier that they would give us a percentage of the money back for every percent that they were off on their protein levels. And we implemented that quality program, and we had that NIR paid for within 6 months of starting that process. If anybody's ever looked at the prices of NIR machines, you could imagine it's a very high price for something like that. So, holding those suppliers accountable is the best thing you can do, and letting them know that you're happy or not happy with the ingredients coming in or the grain.
Yeah, and I know Josh and I have been both out to an organic mill in Western New York, and with the organic commodities being so high cost and such a valuable commodity, we watched an optical sorter cleaner in use, and that was my first experience with it. And I was shocked when we took mycotoxin tests with the fresh grain versus the sorted and cleaned grain, and to see the amount of quality of grain that came out on the other side of that, as well as the reduction in mycotoxins. I know it's very costly for sorters and cleaners, but I think in the long run there are specific needs that I feel are very useful for that opportunity.
Saurabh is nodding his head as well, so I think he's probably in agreement with you there, John. While Josh was presenting again his first presentation, there was quite a few questions coming in on the use of propionic acids and what they can bring to grain storage. And particularly, we've got Musamal, some regions storing grain for more than 6 months. Josh, John, would you like to take a look at that question?
Yeah, propionic acid is a great option for long-term grain storage. I know a lot of our customers use it as a liquid form that sprays it on incoming grain coming into the feed mill for long-term storage. I've also seen feed mills use it as a flushing agent at their feed mill to clean the inside of their equipment. So I'm not sure if that answers his questions completely, but it is a good option for long-term storage. John, you may have more experience than me with selling propionic acid.
Well, and I'm with mold zap on our side of things. We've definitely seen the opportunity of flushing bins with mold zap, and the opportunity to use that to clean out all of those issues with the bin and that flush system. Actually, you and I were out in a mill in Indiana or Illinois, and you were talking to me about the flush procedures that they were using on that probe side. And I think that's important. And I also think, there are some mills that I work with that if they're using wet feeds in the summer, and we know that they have the opportunity to collect moisture such as steam flake corns or some of these wet calf feeds or horse feeds or feeds with some molasses in it. A lot of these mills that I work with, when we have heat and humidity in bagged feeds, they will actually add a certain amount of 1 to 2 pounds per ton of a mold sap or a propionic acid to kind of help secure that feed and to make sure that it's a little more on the stable side. So yeah, I think the plan of using a prop acid product is a really good idea, both from the flush side as well as the stability side on these feeds, especially in humid conditions.
Yeah. I guess the only thing I would add is it's a great tool for prevention, but don't think of it as I can receive in a bunch of junk grain and it's going to fix my problem, if that makes sense. You still have to have those quality procedures in place at receiving for it to be effective.
100%.
Good point, Josh. Staying with you, Josh, you talked about aeration and the importance of that in grain storage. What is the best time for aerating grain? And I'm guessing it's potentially the time of the day the question is referring to during the winter in colder conditions. Do you have any specific criteria on this?
No, you really just have to get good at filling it out, I guess. Anytime you have, seasonal changes, anytime you see some real humid days, things like that, you may want to consider running your fans at night when it's less humid. It's hard. Grain aeration is something that guys that have been doing it a long time are very good at because they have experience in this feeling of the outside conditions and how it's going to affect their grain. So yeah, I would say make sure you're just consistently paying attention to it and adjusting it accordingly. I guess I would say running them is better than not running them all the time. You know what I mean? So anytime you're in question about it, I would definitely err to the side of caution instead of trying to get away with not running your fans at all.
John, should be pretty straightforward questions on Raptor and Rapiread.
Sure.
Talking about aflatoxin, are we looking at total aflatoxin in terms of results, or are we getting B1, B2, G1, and G2, etc.? And secondly, just to clarify, we are testing for ochratoxin, right, with Raptor?
Yes, in regards to aflatoxin, we will get a total aflatoxin number with the quick tests or the lateral flow strips or the Raptor that we're utilizing. So we're getting a total aflatoxin. Obviously, with the 37 plus, we're able to separate those out and look at the derivatives of aflatoxin. And we can kind of do it on both sides, but primarily with the Raptor. To answer that question, we're just getting a total AFLA number. In regards to ochre, yes, you can test for ochratoxin. I don't utilize the ochratoxin test nearly as much, but it's interesting as I manage and look at the world usage of different mycotoxin testing that I do see ochratoxin in other countries in say Brazil, India, South America. You see it in different places where you're going to have a signature that's going to be more predominant, that you're going to see these ochratoxin issues. So yeah, I do see it. We do test for it, and it seems to be a very successful test.
John, speaking of testing, NIR has been mentioned a few times today in relation to quality control at the feed mill, and we know it's widely used, I guess, for testing parameters such as protein, etc. When it comes to mycotoxins, what are your thoughts around NIR?
I think as an industry, we're getting there. It's still potentially cost prohibitive. I know that there are some mills and some situations similar to what Josh was talking about, where they do have onboard in mill testing for more on that quality side, more on the protein side, and then different parameters there. There's been a lot of work done, both research from university, and actually I was part of a Cornell research program that they were looking at last year that was looking at NIR in corn to kind of identify vomitoxin. So I think there's potential there. I think we're still a few years off from getting that down to where we need to be. And I think obviously on a cost side, as well as a research side. I think at least on the mycotoxin side, we're getting there, but I think on the quality side, I think we're already there. It just can be cost prohibitive depending on the mills.
Great. Thank you, John and Josh. We'll come back to you with a few more after, but for the moment, we'll go to Saurabh, who, if you could kindly come off mute. Saurabh, thank you for a fascinating presentation and lots of new developments in that whole area of sorting. There's a potential perception in the feed industry, or the animal feed industry in particular, that this type of technology is more relatable to food production, and from a throughput perspective, it's more applicable there. What are your own thoughts on that? For an example, a feed mill producing 1,000 ton of feed a day, are we looking at applications at that type of level?
Yeah, absolutely. So we already have installed base in the feed industry. So where we're looking at removing DON from the wheat and ergot, but not only that, but aflatoxin as well. So in maize, I gave you an example on how we can do it, do a good job there. The capacity as well for wheat and rye, 8 tons an hour per shoot. So our machines come with 7 modules, and they're modular machines, so you can have multiple of these. Cost is definitely a topic. Ultimately, I answered one of the questions in there. What do you do with the reject of the LumoVision as well? That's an interesting topic, because ultimately it's, in essence, really contaminated product full of aflatoxin. One avenue that we've explored, could we then put that product to insect farms as well, because the larva coming out from that is not really affected by toxin. That's one of the species we found which which can eat this stuff and still doesn't affect their produce in the end.
So lots still to learn potentially.
Lots still to learn, and we are here. We're still working quite hard. This is a topic very close to Bühler, because they would like to be the forefront of food safety and food security. And we continue development in this sector. We already have technologies that work. Now it's a case of just making a cost-based model for the customer.
You talked a bit about ergot in the presentation, Saurabh, and it's certainly a toxin that, depending on where we are in the world, can be a greater or a lesser challenge. How easy is it for your machines or sorters to detect ergot fungus, and under what conditions do you see it attacking rye?
Yeah, so ergot is an interesting thing. So ergot fungus is easily recognized. It attaches itself during the flowering of the grass and cereals and develops into blue-black crane-like structure up to 4 centimeters in length and approximately 3 millimeter in width at the time when it's ripe. Ergot fungus can infest all types of cereals, but it's primarily found in rye. Now, infections can occur more frequently during a damp spring or a hot summer. For our optical sorter, it's quite easy to see ergot infection, and especially the SORTEX H SpectraVision, which is equipped with both full RGB cameras and in-gas technology, so the NIR technology that you were talking about. With that kind of lighting condition, we can easily see ergot. Our efficiencies are 99%, almost 100%.
John, I think our friends in Canada would probably be delighted to hear about that. It's a common challenge that we see coming through each year in our harvest analysis in that region in particular. Thank you, Saurabh. We may have to come back to you, but for now we may just go back to, I think it was John next. Let me see. John, yes, it was quickly. I think you showed Apple examples when you were looking at RapUread on your presentation. It can also work on Android, right? On Android cell phones and tablets and so on.
Yes, that's correct. Yeah, I know that initially I look at it as, it depends on how many people are doing the testing within an individual mill or an individual situation. And oftentimes you can use your own cell phone and have the ability to have that app on your cell phone. But if we have multiple users testing for mycotoxins, depending on the shift that they're on, then we have multiple people and multiple users using that. So honestly, when I work with some of these large integrators and some of these large feed mill chains, I almost really would rather have a dedicated iPad or a tablet, just a cheap tablet that has internet access, Wi-Fi access, and has the ability to have, be modern, where we're able to download the Mycotoxin app, or the RapiRead app, because to me, I like to have that as a dedicated system, so we don't have 5 phones going around, and then when we have turnover, that information is still potentially there. Not granted, the risk is not huge, but yet at the same time, with the level of security that we do need, I would much rather prefer having and with the cost of these, they're pretty cheap. I would much prefer either a cell phone that's dedicated for this, or an iPad or a tablet for this situation, just so it stays more in-house, more secure, more universal, less users, less risk, and less time for error. So to me, I think as we progress along, I think that's probably the best avenue to go.
Thank you, John. Josh, we're going to come back to you for a moment, and this is an interesting question from Ahmed. Do you test the presence of mycotoxins before filling the mill, then give the approval, or should you fill, then test?
Ideally, you would test before filling the mill. I understand that that's not always the easiest thing to do at a feed mill, and there are ways of going about it, like implementing a mycotoxin binder if you do have an issue that you can't mitigate at receiving. So you can do it either way. Obviously, the best case scenario is that those mycotoxins never enter your mill. But if you are finding problems inside your feed mill after receiving, or you don't have the capabilities of testing for mycotoxins, you can always implement a mycotoxin binder. So, yep.
Very good. And Josh, one last question for you today. We've kept you busy here. It's from Brian. He is asking, what is the best way to prevent grain from spoiling higher up in grain tanks when the grain is constantly being rotated through them?
Okay. Yeah. The best thing you can do, Brian, is get those things empty. I don't know your scenario at your bin, but I think he's talking about just constantly dumping grain on top of on the top of a bin. But if there's any way where you can rotate bins to where you can actually physically get all that grain out of there and get that stuff used up, that would be the most ideal scenario. Yeah, and if he's talking about the way he's worded that, it sounds like maybe he's got ingredient bins, not necessarily like large grain bins. So that's what I would recommend, having a way of getting your bins emptied, whether that be having 2 bins dedicated to each ingredient if possible, and then making sure those run empty and get that stuff cleaned.
Josh, I'm sorry, I'm going to come back to you with one more question.
That's all right.
And I think this may depend on what part of the world someone is in, but it's a good question. And when we think about education, and that's the theme of the program in general, what are the qualifications required to run any feed mill? And I guess there's a number of variables within that, but you've been through the sector for a good while now, so maybe you can have his a quick background on that.
The qualifications to run a feed mill. Yeah, I guess that's a hard one. I would definitely say that just time in the industry would be the biggest qualification. There's no substitute for experiences and bad experiences, I guess. And that does come along with being in the industry a long time. Everybody that's in there is going to have bad experiences. But I don't necessarily think you have to have some type of a doctorate or anything like that to run a feed mill. At the same time, there are so many moving parts at a feed mill. It's very hard to have a very young person come into a feed mill and experience that. I think the biggest thing is to run a feed mill. You have to be really good with people, even more so than knowing the feed mill in and out. So there's definitely some things to think about, I guess. Your if you're going to run a feed mill, you're really running the people that are running the feed mill, right? So, yeah, I don't know if that's a good answer or not, but it's a
think you're
tough
right,
one to
Josh.
answer.
And I think as we see labor challenges only getting tighter across the world, the opportunities within the feed milling sector, they will be certainly presenting themselves over the next few years. And I guess within that, we'll see automation, and we often talked about that, Josh, at our previous workshops, and it's probably something we'll look at over the coming sessions as well. John, to finish with you, and we've not talked about binders or mycotoxin adsorbents today, but we have you here, and I know you like to talk about them. So we've got a question from Will-Ann, and asking, does the mycotoxin adsorbent solve the problem in the final feed? So we've tested the feed, we've segregated it, we've done all the QC, but we still have mycotoxins in our final feed. What is the financial impact of treating the effect and not the cause of mycotoxin occurrence?
There's a lot to unpack there.
Yes.
No, and I think it's a great question. Depending on the part of the world you're in, looking at absorbance versus, mitigation strategies. There's plenty of research that has been done that show performance enhancements on both feed conversion, average daily gain, milk production, somatic cell count. So I've probably hit a lot of different species there, but there's a lot of research that shows utilizing the correct solution will benefit the production of the animal in lieu of some of the mycotoxin levels that might be higher risk in finished feeds than what we would like to see. I think that, you can look at the research and you can see the information. I like to say that I would definitely, it's almost like going to a doctor. To me, there's a lot of people that will throw in different countries that'll throw a clay type of product in, and clays work great on aflatoxin and some a little bit on zearalenone. But, when you start looking at the other mycotoxins, there's not a lot of productive or positive research on that. So I think when you start looking at different methods, it's almost like you've got to know what you have and what you're dealing with first before you kind of try to mitigate that source, depending on whether it's dilution or segregation or whatever your mitigation source or process is. So I think definitely I have seen performance changes on farm. I'm on farm very often, and you could definitely see when you start to look at, mitigation strategies, whether it's on farm or elsewhere, that there's definite performance enhancements in the animal. So yeah, I guess that's probably the best way I can describe it.
Yeah, thank you, John. And certainly, as we look at nutrition specifically, again, it's a topic that we'll probably cover off in some of the further sessions throughout the year. We've always had a good response to those presentations and discussions over the last few years. So we've got through a lot there. So thank you to all of you for sending in lots of great questions, and thanks to our speakers again for helping to address all of those. So and again, to our attendees, we appreciate you taking the time out of your busy day to join our feed production workshop. As I said, our plan is to deliver some further workshops this year. We don't have any firm dates on those yet, but we plan to do at least another 2 of these type of sessions. So please keep an eye on your inbox, as we'll be sharing more information on that over the coming weeks. In the meantime, if there's questions that you feel weren't totally answered, or if you've got other topics that you want to put to our speakers, feel free to send them through to us after the event, and we'll be able to direct them to the relevant people. So once again, thanks everyone for joining. Thanks to all of our speakers for sharing such great insights, and have a great rest of the day.
Thank you.
Thanks.
Thank you.